You're welcome back from break. Let's continue from where we stopped. The next example here, example 6, borders on histogram. We are done with pie chart. The question is, the histogram represents the weight of students who traveled out for an examination. How many students made the trip? This kind of question is common in histogram, in bar charts. Don't forget, the same approach we are going to use now to answer it is the same approach you use even in bar charts. How many students made the trip? Use the head of each bar to count the number of students that made the trip. How? You don't just do what majority of people do. Majority of people, when this kind of question is asked, they add up the numbers here. And unfortunately, they might find it among the options and they grab it. Don't do that. This is how to go about it. This first bar tallies with 2. You write 2 plus. You want to know the total number of students that made the trip. Head of this bar on 3 plus 3 plus head of this bar on 5 plus 5. The head of this bar on 6 plus head of this on 8 plus head of this. You know, I take it step by step like that. So the head of this against 4 plus head of this against 1. 2 plus 3, 5 plus 5, 10 plus 6, that's 16. 16 plus 4, 20 plus 8, 28 plus 1, that's 29. That's the total number of students that made the trip. And that tallies with option B. Option B. Example 7. If you look at this example 7 very well, you realize it's the same diagram. Yes. It's that same diagram that is used to answer 2 questions in the exam. So I separate them for you in order to avoid confusion. The next one now is, the histogram represents the weight of students who traveled out for an examination. Find the modal weight. We are to find the modal weight in this case. So, to use histogram to find mode, that is the point. How do we do it? Locate the tallest bar, this is the tallest bar. Then, the bars to the right and to the left, closest to the tallest bar, are what you need now. This is the tallest bar. This bar to the right, which is the nearest. And this bar, which is the nearest to it, it has contact to the tallest bar at this point. This one also has the contact to the tallest bar at this point. You take your long ruler. From this diagonal, you create this line to this point. From this, create it as well to this point. Then take your ruler to trace this meeting point down straight with your ruler. If you look at it very well, you see that that line does not land at the center, at the midpoint of 40 and 50. No. If it does, then we will say it is 45. It does not. So, even though it is not graduated, it can be given like that also in the exam, that it is not graduated. Yet, you will be expected to use common sense to take the answer that is the closest to the reality. So in the option, look at it, we have 40 kg. It cannot be, it's more than 40 kg. We have 42 kg, that is the answer. Because we have 48 kg, that one is close to 50 kg. It is not. We have 50 kg, no. The answer is 42 kg, option B. You can see it is easy to do. Once you do it like this, then evaluate what is the value. If this is 40 and this is 50, what is this? And if it is graduated, you use the graduated lines to discover your answer. But even without graduation, you can see here that the answer is 42 kg, option B. Example 8. We have bar chart in this example. The bar chart above shows the distribution of SS2 students in a school. Find the total number of students, that is, total number of those SS2 students. We have, in SS2A, we have 45 of them. In SS2B, we have 60 of them. In SS2C, we have 30 of them. In SS2D, we have 45 of them. What is the total number of SS2 students? See what you must avoid. It is common to students to add up the numbers here in an attempt to answer this question. It is wrong. If you add up this number, what will that give you? 15 plus 30, that is 45. 45 plus 45 is 90. 90 plus 60 is 150. That is option D, which is very, very wrong. Don't go for it. It's wrong. How should you do it? You have, just as we did that example of histogram, the same thing we are expected to do here. Add the bar. The head of this bar, that is the number of students in SS2A, is 45, plus number of students in SS2B is 60, plus number of students in SS2C is 30, plus number of students in SS2D is 45 as well. Adding them together, 45 plus 45 is 90. 30 plus 60 is another 90. 90 plus 90 is 180. So option A is the correct answer. 180 students are in the SS2. Let's consider example 9. The bar chart above shows the distribution of SS2 students in a school. What fraction of the students is in class A? You notice that this diagram and the body of the question is for example 8. Yes, it's the same diagram and body of question that is used to answer 2 questions in the exam, in the UTME. It is used to answer 2 questions. So in example 8 that I gave to you, that's the first question. In this example 9, that's the second question. And what's the question? What fraction of the students is in class A? The first thing to do is, what is the total number of the students in SS2? I've taught you in example 8 how to get that. Total number of students in class A is 45, plus 60 in class B, plus 30 in class C, plus 45 in class D, and that gives us a total of 180 students. Now, what fraction of the students is in class A? You see, class A is 45 students are in class A, all over total number of students in SS2. That will give us 1 over 4. So the fraction is 1 over 4, which tallies with option B. Option B is the correct answer. Example 10. This is on OGIF, that is cumulative frequency curve. Please pay attention. The cumulative frequency curve shows the distribution of the scores of 50 students in an examination. Find the 36th percentile score. Don't forget that the scores here are given in percentage. Marks in percentage. You can see it in the graph. So we are to find the 36th percentile score. Percentile in cumulative frequency curve is just like percentage. It's like finding percentage. It's just a way of packaging. We give it percentile on cumulative frequency curve. So 36th percentile is 36% of the total 50, total cumulative. The total cumulative here is 50. Don't forget, the highest number here, which is 50, is the cumulative frequency, total cumulative. So, we have this. Cutting this, we have 18 of it. 36 over 100 times 50, we have 18. You locate that 18 in the cumulative frequency. The 18 will be around this place. If this is 10, 18 will be around this place. You trace it until you get to the curve. Getting to the curve, trace it down. Can you see what I'm doing? This value, the value at this point is our answer. The value at this point will be around 27, 28 and thereabouts. And in the exam, you will not be given the confusing values. Our answer here will be 20-something. It's most likely that only 120-something will appear in the options. Just like we see in the options, our answer is option B, 28%. You know, the scores are given in percentage, marks in percentage. So our correct answer is option B, which is 28%. Look at it, 20. This is more than 25, the midway of 20 and 30. So that is 28. Option B is the correct answer. Example 11. You notice that we are using the same cumulative frequency graph to answer the question. The question required to be answered from that graph has been exhausted. But I use the same graph to answer some other questions that you will definitely come across in the exam, in order not to be drawing always. So, let's use this to answer another question. The cumulative frequency curve shows the distribution of the scores of 50 students in an examination. Find the median mark. You know, the marks here are given in percentage. So find the median mark. Well, we do this under quartiles. Under what? Quartiles. Quartiles in cumulative frequency curve OGIF. We have 3 quartiles. First quartile, represented by Q1, means 1/4 of the total cumulative. When you get it, you trace it on the graph to obtain the actual value. The Q2 is 1/2, which is second quartile. You know, Q1 is first quartile, which is drawn from the word quartile. We call it quartile, but it's drawn from the word quarter. So second quartile, which is Q2, is 1/2. It is actually 2/4, which is half. And that is of cumulative frequency. And the third quartile is Q3. And that third quartile is otherwise known as upper quartile. The first quartile is otherwise known as lower quartile. Meanwhile, the second quartile is otherwise called median or middle quartile. Median or second quartile. So this is 3/4 of the cumulative. Now, how do we calculate it? Let's calculate that before I explain some other things on this. Find the median mark. To find the median mark in this regard, the median mark is the second quartile. So we have median mark. Median mark is 1/2 times, what's the total cumulative here? 50. And that gives 25. The 25 will be traced from the cumulative here. The 25 is here, is around this place. So we trace it until we come to the graph, to the OGIF. From the OGIF, trace it to the score line. So you realize here that it is in the midpoint of 30 and 40, which is 35. Therefore, from graph, you trace this. If it is in YX, you are doing it. The same thing you are doing. This is the value. You trace it here. From graph, Q2 equals 35%. And that tallies with option D. That tallies with option D there. Do you understand? Good. Let's consider example 12 using this graph as well. The cumulative frequency curve shows the distribution of the scores of 50 students in an examination. The interquartile range of the graph above is given by, what do we mean by interquartile range? Look up here. You know, we say this is first quartile, second quartile, third quartile. Range normally, you know that third quartile should be greater. Middle quartile should be greater than first quartile. First quartile is the lowest among them all. Therefore, range normally is equal to highest minus lowest. Do you understand? Therefore, range among quartiles is what we call interquartile range. Range normally is highest value minus lowest value. That's range normally. But what is interquartile range? Range among quartiles. And we have just 3 quartiles. First quartile, second quartile, third quartile. And third quartile is the highest. First quartile is the lowest. Therefore, interquartile range will be the highest, Q3, minus the lowest, Q1. Therefore, the correct option here is option B. Option B is the correct option. Let me use this avenue to explain to you. We have answered that question because we are drawing the curtain on statistics. You are going to do more practice with what you have learned now, then you get the rest. But let me tell you this, that while this Q3 minus Q1 represents interquartile range, we have something we call semi-interquartile range. Will be half of Q3 minus Q1. That means Q3 minus Q1 divided by 2. That is semi-interquartile range, which could be written as half of Q3 minus Q1. It could be written like this, and it's the same thing as this. This is what we call semi-interquartile range. You can see it in the option, but it is not what is required there. So that is it. And finally, what if you are to calculate from the graph? You are given the graph, and you are to calculate the interquartile range. How do you go about it? The interquartile range will be, you obtain the lower quartile, which is at the upper quartile, which is from here. From this graph, the upper quartile is 3 over 4 of 50. So whatever this gives you as value, you trace it from this graph. When you trace it from this graph, let's say you get 30. I'm just taking something. I'm not doing it. I'm just explaining to you. When you find the value of this, trace it to wherever it is here. Let's say you get 30. That 30 minus the lower quartile is 1 over 4 of 50. Will give you something. It will give you something like 12.5. Trace that 12.5 here, whatever it gives you, trace it here. When you get to the curve, come down. Let's say you get 22. It is that 22 you subtract from 30. Whatever you get is the actual value for interquartile range. With that brief explanation, you should be able to do it if it comes out like that, whether in WAEC or in JAMB. So that is where we are going to draw the curtain on statistics.